Hello, everyone, and welcome to today's D-Zone webinar, Securing the Untrusted Agentic Development Layer. I'm Ken Underhill, and I'll be your host for today's session. AI agents are rapidly becoming embedded throughout the software development lifecycle. What started as productivity tooling for engineering teams is quickly evolving into autonomous systems capable of writing code, integrating services, accessing sensitive data, and making development decisions with limited oversight. At the same time, adoption is expanding far beyond traditional engineering teams, introducing a new generation of citizen developers who are building with AI-powered tooling, often without formal security review or governance. This shift is creating an entirely new attack surface inside the development layer itself. Organizations are now facing risks tied to untrusted agent behavior, insecure integrations, shadow AI adoption, and build time prompt injection attacks that can compromise environments long before code ever reaches production. Traditional runtime defenses alone are no longer enough. Now, before we get started, just a quick bit of housekeeping. Today's session is being recorded and we'll send the on-demand recording after the event. If you have questions during the presentation at all, please submit them using the Q&A panel, and the Sneak team will follow up afterward where appropriate. In today's session, you're going to gain practical insights into how to identify and neutralize toxic MCP skills and malicious agent capabilities before they connect to your environment. You'll also learn strategies for defending development sessions against build time prompt injection and credential exfiltration attempts. And you'll learn approaches for scaling secure AI adoption through automated governance models that support speed and autonomy of modern development teams. Now, I'm pleased to introduce today's speaker. Joining us is Brendan Hahn, Senior Product Marketing Manager at Sneak. Brendan works closely with organizations navigating the evolving intersection of AI-driven development and application security, helping teams understand how to securely adopt emerging technologies without slowing down innovation. In today's session, Brendan will explore what it means to build a secure at inception model for agentic development and how organizations can create environments where developers and their AI agents can move fast while staying secure. Brendan, thanks for joining us today, and let's get started.
Hello, everyone, and welcome to our session today, Securing the Untrusted Agentic Development Layer. Right now, we are in a unique moment where the rate of change driven by AI is forcing us to completely rethink how we secure the development lifecycle, and I think this is one of the most critical shifts in modern software development. Before we jump into it, I want to thank you for joining today. As a quick intro, my name is Brendan Hahn. I'm a Senior Product Marketing Manager at Sneak, and I've been working at the intersection of development and security for almost a decade. There has never been a more exciting time to be in the space, in my opinion, so I am super excited that you're here. The core thesis of this session is that development is shifting from human-led creation to agentic orchestration. As AI agents move from being a nice-to-have to active participants in the SDLC or ADLC, agentic development lifecycle, security is falling behind. We must navigate a new frontier where risk is introduced long before traditional runtime guardrails can intervene. To enable safe adoption at scale, we have to move toward a secure at inception model that validates the system producing code, not just the code itself. As we talk about how AI has impacted development, I won't backtrack all the way to waterfall development. Instead, we'll oversimplify a little bit and break the DevSecOps infinity loop into 4 stages. It starts with developers writing code, then an application gets built and deployed to production. And DevSecOps and shift-left approaches are really about embedding security into those stages. As developers are writing code, integrating preventative security testing into the IDE allows them to find and fix issues early. Teams with more mature secure development practices may use the pull request as a point of enforcement, checking the pull request itself for security issues and blocking it from being merged if a policy breaking issue is found. Once an app is deployment ready, runtime assessments like dynamic application security testing or DAST may be used to find more issues. And then, once it's deployed to production, teams have to use monitoring and detection and response tools. I want to be clear, I'm not saying that doing these things is not important or that this approach is outdated, but AI is having a dramatic impact on every single one of these stages. The CEO of Anthropic made a prediction in March of 2025 that seemed incredible at the time. He bet that by the end of the year, AI would be writing the vast majority of code, and soon, nearly all of it. We are seeing this reality play out through vibe coding and developers orchestrating many agents at once. Take Claude Cowork, for example. It was built in just 10 days. And when asked how much of it was written by Claude Code, the creator's response was simply all of it. Things that used to take teams multiple quarters to build are now happening with fewer people in less time. While this innovation is exciting, as security professionals, we have to be aware that this expands and evolves our attack surface at machine speed. As organizations move up the AI maturity curve, they're adopting a completely new system that doesn't just expand their attack surface, it evolves it at machine speed. There are entirely new threat vectors that we're introducing that are still being discovered. Attackers are adopting AI systems too, getting from issue to exploit faster and chaining them together autonomously. I won't go through all of these on the slide, but let's double click on chaining just for a second. There are a few ways this is already playing out in the market. There are relay chains where one agent is used to find a vulnerability, a second agent is used to craft the exploit code, and a third agent is used to execute it. There's also the latest frontier models like Mythos from Anthropic that can chain multiple low severity issues that humans might ignore or accept into a single critical exploit. So, we're faced with a compounding risk problem. These AI systems are doing incredible things for a company's velocity, dramatically increasing the speed and volume of code being delivered. But they're introducing both traditional issues and novel attack vectors with it. And as I mentioned, AI is being used to accelerate the time from issue to exploit as well. And this was all happening before we got to the world of fully agentic AI with autonomous agents like OpenClaw. If you haven't seen OpenClaw before, it's a self-hosted AI agent that people are using as proactive personal assistants, connecting them to LLMs to manage local files, use messaging apps, and autonomously execute real-world tasks like managing emails, scheduling meetings, and even running shell commands. It is also widely recognized as the fastest growing repo in GitHub's history, as it surged from roughly 9,000 to over 200,000 stars in approximately 60 days. Again, these tools are providing unbelievable productivity, but some spectacular researchers from Sneak dove into the skills, the plugins that give AI agents real execution power, and found that 37% contain at least one security issue and 13% have a critical security issue. And these risks aren't theoretical. They're happening today with catastrophic consequences. There's the database deletion problem. We've seen it play out a couple of times, but a Replit agent went rogue during a code freeze, ignored explicit instructions, and deleted a production database in just 9 seconds. The user reported that they told it to stop, but it was already too late. and months of work were destroyed. We've seen documented cases of AI systems resorting to blackmailing developers if they're told they will be removed. And hallucinations are another real risk. A user reported an unknown GitHub code base being deployed to their team. Investigations showed an agent run on Opus 4.6 had hallucinated a public repo ID and used an API to deploy it autonomously. So all of this is really happening today. So let's circle back to our simplified DevSecOps steps. AI raises questions across every stage of this process. When AI coding assistants are generating more code faster than ever, how do you prevent issues? When volume of issues in that code balloons, how do you effectively prioritize them? And can you use AI to remediate them? As we progress through the process, how do you maintain a developer-friendly workflow? And how do you avoid a purely reactive program where issues are found in production and then get thrown over the wall back to development later? The reality is that the AI security landscape is fractured and risk is expanding through several specific vectors. The attack surface of agents are much more dynamic. Tool hijacking can be used by attackers to take control of the tools agents use to interact with systems. Agents may autonomously create other shadow agents without oversight. Covert signal manipulation comes from manipulating the inputs or prompts an agent receives during a dev session. And autonomous credential harvesting is when agents are tricked into servicing or using developer creds. And the agent supply chain also introduces risks. Agents now autonomously fetch model weights, data sets, and third-party skills, often through the Model Context Protocol, or MCP, without human vetting. This introduces toxic MCP flows where unvetted skills can lead to SSRF or remote code execution. Server-side request forgery is even more dangerous in an agentic environment because agents often have broad network access to reach internal databases, model weights, or cloud metadata services. In this attack scenario, an agent autonomously fetches a third-party skill or MCP server that hasn't been vetted. The skill is designed to fetch a URL and summarize it. An attacker provides a prompt that forces the agent to call an internal IP. And because the agent is running within your trusted perimeter, it can bypass firewalls to exfiltrate identity access management credentials, internal API keys, or even sensitive data sets used for RAG. And on the RCE side, this is the holy grail for attackers. In an agentic context, RCE occurs when an unvetted tool allows an attacker to execute arbitrary shell commands on the host system where the agent is running. Agents are increasingly given real execution power to run scripts, manage local files, or execute shell commands like the OpenClaw agent. A toxic MCP skill might have a hidden backdoor or a poisoned update. And once that agent connects to this malicious skill, the attacker can run commands like npm run db push to wipe databases, as seen in the Replit incident, or install a persistent backdoor into the developer's local environment. So attackers are also using AI to target these vulnerabilities in seconds, meaning AppSec can no longer rely on a human-paced backlog. We also have to talk about the expansion of the developer persona. We are seeing a rise in citizen developers, non-traditional builders using agentic tools to modify production systems. This has led to vibe coding, where teams prioritize the speed of AI generation over architectural vigor. It often results in shadow adoption, where agents operate with full system credentials but limited oversight. And it also introduces traditional security issues. I will pick on myself here and tell a real story. The Sneak marketing team is super bullish on how we can use AI for go-to-market. So we've introduced marketing run AI hackathons where we've set a time to focus on a project that we think will help our teams. This is a real screenshot from an early version of my first project that I called Blast Off Bot. And the idea was that I could put together a AI tool that could automate some of the launch comms that we create. I used Gemini to put this project together. And at one point, I hard coded my Google Studio API key into the source code in order to get that program to run on the judge's computers locally. Not a great look when you work at an AI security company. Good news though, before the competition was over, actually, as soon as I put the API key in, Sneak flagged it and helped me fix it. But there's real risk here. Another marketer at another company who is less security aware than I am would push this live and start to share it. Citizen developers and vibe coded applications pose real risk. Just another real world impact check. If we look back not far to March, there were 4 major AI and software supply chain security incidents that hit in a single week. And they weren't edge cases. They hit the most trusted, most widely adopted tools in the ecosystem, not a vibe coded marketing hackathon toy app like the one I built. The Team PCP compromised Aqua Security's Trivy vulnerability scanner by force pushing malicious code into GitHub Actions and publishing infected binaries. The attack expanded to checkmarks with Team PCP using credentials stolen from the Trivy breach to poison checkmarks kicks and AST GitHub Actions. The Light LLM attack shows that your AI gateway is also your biggest credential vault. Light LLM holds the keys to every AI provider your team connects to: OpenAI, Anthropic, Google, all of them. When attackers compromised it, they didn't just get one key. They got all of them, plus Kubernetes secrets, SSH keys, and cloud credentials. Do you even know which of your teams is running Light LLM and what it has access to? In the case of Axios, this was a supply chain attack that auto installs. It wasn't like an obscure package. It was Axios, one of the most fundamental libraries in JavaScript. A state actor hijacked a maintainer's account and published a poisoned update that ran automatically on install, no click required, no user interaction. If a CI/CD pipeline pulled a fresh install during a 2-hour window, you had a rat on your machine. Sneak flagged this for customers in real time, but if you're not scanning your dependency tree continuously, you're relying on someone else to catch it first. For Anthropic, arguably the most safety-conscious AI company in the world, in 1 week, they accidentally leaked their entire product source code through a packaging error and exposed nearly 3,000 internal files, including details about an unreleased model they themselves say possess unpresented cyber risk, through a misconfigured CMS. The lesson here is that if it can happen to Anthropic, it can happen inside of your organization too. Shadow AI, misconfigured pipelines, and untracked dependencies pose real risk. Most security tools would have caught one piece of this. A traditional SCA scanner might flag a known vulnerability in a dependency, but these incidents aren't about known CVEs. They're about compromised supply chains, stolen credentials, poisoned updates, and AI components that nobody in the org is even tracking. So, how do you validate the system? It's a big ask. Agents are using tools like MCP servers, skills, and external tools to get tasks done. They're running tools, scripts, and getting access to systems, and then generating code and dependencies at a volume and rate that development and security can't possibly keep up with. So, to secure development today, you need to focus on 4 key areas. You need to secure inputs, vetting MCP servers and tools before agents interact with them to eliminate the shadow AI supply chain. You have to govern behavior, enforcing real-time policies to stop destructive actions or privilege escalations. You need trusted output, scanning and fixing AI-generated code at the moment of creation before it reaches the repo. And you need to maintain a live AI bill of materials to inventory every model and agentic tool. An AI bomb goes beyond dependencies, tracking model weights, data sets, and prompt templates. It includes an MCP inventory because you need to inventory every MCP server and skill that an agent has access to, as these are the new entry points for attackers. And you need to understand the risks associated with those components. How do you decide if a specific agentic tool is safe before a developer connects it to their environment? Well, that's easier said than done, which is why Snyk introduced the prescriptive path to operationalizing AI security. It starts with stabilizing your environment. You need to start with foundational visibility into your application estate because you can't secure what you can't see. Then you can stop the bleed by implementing preventative guardrails. With Snyk, that means integrating testing into the moment of code creation, whether it's written by a human or generated by AI. Then you can start to optimize to reduce risk effectively. Strategically prioritize where to spend your focus and energy based on important risk factors, and use those signals along with AI to remediate issues at scale. You have to go beyond looking at CVEs and things like reachability. In my opinion, this is the most critical piece of the prescriptive path today. AI-generated fixes are great, and they help developers solve issues one at a time or in their development workflow. But with the speed at which attackers can go from issue to exploit, and AI systems like Mythos proving that several low severity issues can be chained together to create serious exploits, I think there's going to be a world where security teams are looking to get to backlog 0, where all issues are remediated. Honestly, that's a topic for another talk, though. Once you drive faster remediation, you can prove the impact of your program, measure performance, and prove compliance. Only then can you scale to orchestration through agents. This all comes together with the Snyk platform. It meets teams where they are, bridging the gap between AI-accelerated DevSecOps and AI-native software, empowering developers to maintain visibility and vet inputs. It proactively finds weaknesses in AI systems and enforces real-time policies, helping developers remediate issues. And it's built on our heritage of developer-first security. Our engines provide best-in-class accuracy directly in traditional development workflows and provide intelligence to AI-powered workflows that help accelerate delivery. By following the prescriptive path, starting with visibility and prevention, prioritizing and remediating, and scaling to agentic orchestration, teams can achieve proactive AI governance. And our customers who follow this path and embrace the platform actually unlock AI innovation. They move from fragmented visibility to unified awareness. Instead of a gap between the velocity of development and security, they get AI fortifying prevention at speed, and alert fatigue is cured with contextual prioritization. There's a customer success story on the Sneak homepage that is a real life example of this in action. At Yalo, not only did they see a 90% reduction in noise, they also embraced the full Sneak platform, covering their complete risk landscape. As they lean into AI, they know that Sneak will partner with them to secure it. I genuinely believe that this is the path forward. In a world where AI writes code 10 times faster, but your security team still reviews it at human speed, you aren't just slowing down. You're accumulating security debt at an exponential rate. Sneak unifies awareness to separate the noise from the signal, allowing teams like Yalo's to actually move the risk needle. And according to the 2025 Forrester Total Economic Impact Report, Sneak customers experience real benefit across the full prescriptive path. AI velocity is unlocked by unmatched scan speed, with a reported 80% decrease in scan times with Sneak. This means your developers aren't waiting around for security results. They stay in their flow state. Teams can optimize risk reduction by accelerating remediation, achieving 60% reduction in remediation time on average. And the programs actually scale, getting a 52% reduced breach exposure with Sneak. All of this amounts to a 288% average return on investment with Sneak. Now, I do have two quick plugs before we close out the session today. If you are using AI coding assistants, whether it's Cursor, Windsurf, Claude Code, or something else, Sneak is available to help you secure the code they generate at inception. You can scan this QR code and get started with just a few clicks. The way it works is as your AI coding assistants are generating code, they will automatically test with Sneak. Sneak will help those AI assistants remediate those issues, and you get served secure code from inception. You can also check out labs.sneak.io/experiments. It's a playground for innovation featuring Sneak's experimental projects. Explore early stage ideas, prototypes, and proof of concepts straight from our engineering and security teams. There is a tool available there today that can scan Sneak AI bombs for specific components. So if you wanted to search for a specific keyword in those AI bombs and then report which targets contain the specified components, you can. It's perfect for identifying which of your Sneak organization targets use specific AI frameworks, models, or libraries. And with that, I want to wrap things up with a huge thank you for sticking with me through this deep dive into the agentic layer. I know that we've covered a lot of ground today, from the incredible innovation of vibe coding to the somewhat terrifying reality of toxic MCP flows and rogue agents. I truly hope today's session gave you a clear-eyed look at the frontier we're all stepping into together. If there are three things I hope you take away and share with your teammates tomorrow, it's these three. 1, development is changing forever. We are moving from human-led creation to agentic orchestration, and that means our security has to be secure at inception rather than just a late-stage check. 2, the attack surface is dynamic. Between unvetted MCP skills, SSRF risks, and machine speed exploits, we can no longer rely on a human-paced security backlog. 3, there is a path forward. You don't have to sacrifice velocity for safety. By following the prescriptive path, stabilizing your visibility, optimizing your remediation, and eventually scaling to agentic orchestration, you can empower your developers to innovate without the fear of a rogue script wiping your production database. Innovation is the goal. but resilience is the requirement. Whether you're a seasoned security leader or a citizen developer just starting to experiment with these tools, I hope you feel more equipped to navigate this new landscape. Thank you so much for your time.
Thank you again to Brendan and this team at Snyk for sharing these insights into the growing security challenges surrounding agentic development environments. As today's session highlighted, organizations are entering a new era where securing software means securing the systems and agents involved in producing that software. From toxic MCP skills and shadow AI risk to build time prompt injection and governance automation, security teams are being asked to rethink how trust is established inside the development lifecycle itself. If you submitted a question during today's session, the Snyk team will follow up directly. And be sure to explore the additional resources shared throughout the webinar to continue learning more about securely scaling AI-assisted development. Thank you again to everyone that joined us today. Keep an eye out in your inbox for the on-demand recording, and we hope to see you at a future D-Zone webinar.